Today's lesson's on exponential functions. We're going to graph them and then analyze the graphs today. So let's look at this function, 2 raised to the x power subtract 6. I have the parent graph, 2 to the x, drawn here. And notice, what does the minus 6 do? The minus 6 will shift the vertical shift down 6 units. So the first thing I want to do is draw my asymptote. If the asymptote started at y equals 0 here, and it shifts down 6 units, the asymptote is now y equals 6. So we're going to shift all our points down 6 units. And now what is our domain? Let's draw a domain line. Here we don't have a vertex, so that means that my graph is going both directions forever. So my domain is all reals. My range, let's draw the range here. My asymptote is going to be the point where I want to make my mark here. That's at -6. The graph is open here, going up. So I have the range is between -6 and infinity, or I could write that as y is greater than -6. Okay, y-intercept, that one looks really easy. It's 0, -5. It appears that my x-intercept is not very easy here. So let's go to our calculator. Let's use our calculator for this. Two to the x power subtract 6. And to find the x-intercept, I need to put 0 in y2. And we're going to try to find the intersection of these two graphs. So I did second trace 5. So here, my calculator has rounded this, so I want to round it to 1 decimal, so 2.6. So 2.60, the order pair 2.60 is my x-intercept. And now let's do increasing and decreasing. If we notice, we're looking at my red graph here, that the red graph never is going down. So that means it's going up between -infinity and infinity. Now let's look at my end behavior. We're going left to -infinity and down. Where does this graph stop going down? It stops going down at -6 because of the asymptote. So we have -infinity, -6. And here it's going up to infinity, right to infinity. Now let's look at the next example. 2 raised to the x plus 5 power. Here, I've drawn the parent again. And what does the plus 5 do here? It's a horizontal shift left 5 units. So if we're going left 5 units, does the asymptote change? No, it doesn't. Still have the same asymptote. Therefore, if my parent had the asymptote of y equals 0 and it shifts left 5, the asymptote stays y equals 0. Domain, again, we go left and right forever. So we have all reals. Range. Draw my range line. we have asymptote at 0. We have an open circle because the graph doesn't touch 0, goes up. So we have between 0 and infinity, or I could say y is greater than 0. Here, x-intercept. Does the graph cross the x-axis? No, it doesn't. So we don't have an x-intercept, so it's none. Y-intercept. Not easy to see on this graph, so let's go to our calculator. To the x plus 5 power. Let's, this time I don't need to go to the graph. Let's go to the table, and I want to look and see where x is 0. So that's 0, 32. So the y-intercept is 0, 32. The ordered pair is 0, 32. Now let's do increasing, decreasing. Notice here we're never decreasing. And we're always going up. So we're increasing between negative infinity and infinity. In behavior, we're going left to negative infinity, down. This time the red goes down and it doesn't go any lower than 0. So negative infinity to 0. We're going up to positive infinity, right to positive infinity. Okay, let's look at this last example. And here we have negative 3, so that's going to be a vertical shift down 3 units. So that's going to change my asymptote down 3 units. So I'm going to move all my points down 3 units, and the plus 1, I'm going to go left 1 unit. So down 3, left 1. So my asymptote is now y equals negative 3. Domain, all reals. Notice here that for exponential functions that the domain is always all reals. Okay. Draw my range line. Asymptote is at negative 3 this time. Open circle as it doesn't touch negative 3. And we're going up. So between negative 3 and infinity. Or we could say y is greater than negative 3. X-intercept, I'm not sure that it's obvious here. So let's go to our calculator. Let's use our calculator. And to find the x-intercept, I want to find the intersection of those two graphs. So I'm going to do second trace 5. Okay, so here I have intersection 0.584. Notice the calculator is rounded again. So let's round to the nearest tenth, 1 decimal place. So we got 0.6. So the order pair 0.60. Y-intercept, that one looks fairly easy. We went down 3 and over to the left 1. So it's the order pair 0, negative 1. If we're not quite sure, let's go back to our calculator and let's use the table. 0 in the x, so 0, negative 1. Decreasing, notice that I never go down. The red never goes down if I'm reading this from left to right. It's always going up, so it's always increasing. in behavior here. We're going left to negative infinity, down to negative 3. Notice that graph stops at negative 3. And we're going up to infinity, right to infinity. Now I have some problems for you to try.